Welcome back to Java Internals Crashcasts. I'm your host Sheila, and today we're wrapping up our season on concurrent collections. We've covered a lot of ground in this season, and we're excited to bring it all together in this summary episode. Victor, are you ready to help our listeners review what we've learned?
Absolutely, Sheila. I'm looking forward to recapping the key points of concurrent collections and helping our listeners solidify their understanding.
Great. Before we dive in, let's start with a quiz question for our listeners. Here's the question. In general, which operation tends to be slower on a concurrent hash map compared to a regular hash map? Read operations or write operations?
That's an excellent question, Sheila. It really makes our listeners think about the trade-offs involved in concurrent collections. Without giving away the answer, I'd encourage our listeners to consider the mechanisms needed to ensure thread safety and how they might impact different types of operations.
Absolutely, Victor. Now, let's begin our summary by reviewing what concurrent collections are and why they're important. Can you give us a quick overview?
Certainly. Concurrent collections are thread-safe versions of standard Java collections designed for use in multi-threaded environments. They provide built-in synchronization mechanisms, allowing multiple threads to access and modify the collection simultaneously without causing data conflicts or inconsistencies.
That's a great starting point. So, if I understand correctly, the main benefit is that we don't have to worry about manually synchronizing access to these collections, right?
That's correct, Sheila, but it goes beyond just convenience. Concurrent collections often provide better scalability and performance compared to manually synchronized collections, especially when many threads are trying to access the collection at the same time.
Interesting. Can you elaborate on that? How do they achieve better scalability?
Sure thing. Many concurrent collections use advanced techniques like lock striping, which is a way of dividing the collection into separate parts that can be locked independently. This allows multiple threads to access different parts of the collection simultaneously, reducing conflicts. For example, ConcurrentHashMap uses this approach, dividing the map into segments that can be locked separately.
That's fascinating. It reminds me of how a busy restaurant might have multiple servers handling different sections to serve customers more efficiently. Now, let's review some of the specific concurrent collections we covered this season. Can you highlight a few key ones?
Absolutely. We covered quite a few, but some standouts include 1. ConcurrentHashMap, a thread-safe version of HashMap with better concurrency. 2. CopyOnWriteArrayList, great for read-heavy scenarios with infrequent modifications. 3. BlockingQueue implementations, useful for producer-consumer patterns. 4. Concurrent skip list map and concurrent skip list set, sorted concurrent collections.
Those are great examples. I remember we talked about CopyOnWriteArrayList having some unique properties. Can you remind our listeners about its characteristics and when it's most useful?
Certainly. CopyOnWriteArrayList is a thread-safe variant of ArrayList, where all modifying operations, add, set, remove, etc., create a fresh copy of the underlying array. This makes it excellent for scenarios where reads greatly outnumber writes, as reads can happen very fast without any synchronization. However, modifications can be expensive, especially for large lists.
That's a great explanation. It's like having a shared notebook where instead of locking pages when someone wants to write, they just make a whole new copy of the notebook with their changes. Efficient for reading, but potentially wasteful for frequent updates.
That's an excellent analogy, Sheila. It really captures the essence of how CopyOnWriteArrayList works.
Now let's talk about some common patterns or best practices when using concurrent collections. What should our listeners keep in mind?
Great question. Here are a few key points. 1. Choose the right collection for your use case. For example, use ConcurrentHashMap for general-purpose concurrent maps, but consider concurrent skip list map if you need a sorted map. 2. Be aware of the consistency guarantees. Concurrent collections often provide weaker consistency guarantees than fully synchronized collections. 3. Use the atomic operations provided by these collections when possible, rather than trying to implement your own compound actions. 4. Remember that while these collections are thread-safe, compound actions on them may still need external synchronization.
Those are really important points, Victor. I'm particularly intrigued by the point about consistency guarantees. Could you elaborate on that a bit more?
Of course, unlike fully synchronized collections, concurrent collections often provide what's called weakly consistent views or iterators. This means that they reflect the state of the collection at some point during the traversal, but not necessarily a consistent snapshot of the entire collection at a single point in time. This trade-off allows for better performance and scalability.
I see. So it's like taking a panoramic photo of a busy street. The final image shows all parts of the street, but not necessarily as they were at the exact same moment, right?
That's a brilliant analogy, Sheila. It perfectly captures the essence of weak consistency in concurrent collections.
Thank you, Victor. Now, as we're wrapping up, let's address a common question. When should developers choose concurrent collections over regular collections with manual synchronization?
That's a crucial question. Generally, concurrent collections are preferable when you need thread safety and good performance under high concurrency. They're especially useful in scenarios where multiple threads frequently access the collection simultaneously. However, if your use case involves simple, low-contention scenarios, regular collections with manual synchronization might be sufficient and potentially more straightforward.
That makes sense. It's all about choosing the right tool for the job. Now, before we conclude, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Certainly, the question was about which operations tend to be slower on a concurrent hash map compared to a regular hash map. The answer is that write operations tend to be slower on a concurrent hash map. This is because write operations need to ensure thread safety, which involves some overhead. Read operations, on the other hand, can often proceed without locking in a concurrent hash map, making them comparatively faster.
Thank you, Victor. That wraps up our summary of concurrent collections. We've covered their importance, key types, best practices, and even delved into some performance considerations. Is there anything else you'd like to add before we sign off?
Just a reminder to our listeners that while concurrent collections are powerful tools, they're not a silver bullet. Always consider your specific use case, performance requirements, and the complexity of your application when choosing between concurrent and non-concurrent collections.
Excellent point, Victor. Thank you for that. And thank you to all our listeners for joining us for this season on concurrent collections. Next season, we'll be diving into advanced topics in Java concurrency, starting with the fork, join framework. Don't forget to subscribe to Java Internal's Crashcasts and leave us a rating if you found this helpful. Until next time, happy coding.